Hi, welcome to the channel Friend for Maths. This is our part 7 video of chapter 1 real numbers, and in this we are going to discuss the last topic of this chapter, revisiting rational numbers and their decimal expansions. Friends, you can go through the previous parts of this chapter in order to get more ideas relating this topic. Okay. And in the ninth standard we have studied that every rational numbers have either a terminating or a non-terminating repeating decimal expansions. We can go through some examples here. We have given some decimal numbers which are terminating. Here 0.375, here is 0.104, and here 0.0875. Next is 23.3408. All are some decimal numbers which are terminating. Terminating means all have an end. And now we are going to change all these decimal numbers into their corresponding rational numbers. Rational numbers are the numbers which are in the fraction form, that is with a numerator and a denominator, isn't it? And now 0.375 can be written as 375 dividing by 1000. Here we take 1000 in the denominator, which has 3 zeros because we have 3 digits after the point. Okay, so we have to divide the number with the 1000, and when taking it as the power of 10 we get 10 cube in the denominator. And next is 0.104, that is equal to 104 dividing by 1000. Here also 3 numbers after the point, so we take 1000 as the denominator, and that is the 10 cube. Next is 0.0875, that will be equal to 875 dividing by 10,000. Here we take 10,000 with 4 zeros, that is because we have 4 digits after the point, and we have 10 raised to 4 as the denominator. Next is 23.3408, that will be equal to 2,33,408 dividing by 10,000. Here also we take 10,000 with 4 zeros, that is because the 4 digits after the point, and we have 2,33,408 dividing by 10 raised to 4. And now we have changed all these decimal numbers which are terminating into their rational number form. And now we are going to do change all these numbers as the product of its prime factors by doing prime factorization method. Okay, we have studied the prime factorization of a number in the previous class, so you can watch that part. And next we are going to change all these numbers as the product of their prime factors. Okay, here 0.375, that is equal to 375 dividing by 10 cube, and the prime factorization of this 375 is 3 into 5 cube, and the prime factorization of 10 is 2 into 5, and 10 cube is 2 cube into 5 cube. And here we can see that the common factors, that is 5 cube in both numerator and the denominator. So we are cancelling this 5 cube, which is the common factor, and now we get 3 by 2 cube. Now this rational number is in the form p by q, that is which have this p and q are co-prime to each other. That means they have no common factors each other. Next is 0.104, that is equal to 104 dividing by 10 cube, that will be equal to the prime factorization of 104 is 13 into 2 cube, and the prime factorization of 10 cube is 2 cube into 5 cube, and cancelling the common factor 2 cube in the numerator and the denominator, we get 13 by 5 cube. Now this is changed into a rational number which has the numerator and the denominator, the numbers are co-prime to each other with no common factors to each other. Okay. Next is 0.0875, that is equal to 875 dividing by 10 raised to 4, and the prime factorization of 875 is 7 into 5 cube, and the prime factorization of 10 raised to 4 is 2 raised to 4 into 5 raised to 4, and cancelling the common factor 5 cube in the numerator and the denominator, we get 7 by 2 raised to 4 into 5 raised to 1. Next is 23.3408, that is equal to 2,33,408 dividing by 10 raised to 4, and the prime factorization of this number is equal to 2 raised to 6 into 7 into 521 dividing by 2 raised to 4 into 5 raised to 4, and cancelling the common factor 2 raised to 4 in the numerator and the denominator, we get 2 square into 7 into 521 dividing by 5 raised to 4. Now all these decimal numbers which are terminate are changed into the rational numbers, which are the numerator and the denominators are co-prime numbers. Okay, and now look at the denominators of each rational numbers. Here all are seen by either 2 raised to n form or 5 raised to m form, or some 2 raised to n into 5 raised to m form, or some 5 raised to m form. So in general we can say that all the denominators are in 2 raised to n into 5 raised to m form. Okay, that is what's saying in the first theorem, that is, let x be a rational number whose decimal expansion terminates. That is, we can take this example. This is a rational number which its decimal expansion terminates, and this x can be expressed in the form p by q, where p and q are co-prime. That is, here we have expressed like this: p and q are co-prime to each other, that is, no common factors to each other, and this q, the prime factorization of this q will be then the form 2 raised to n into 5 raised to m form, where n and m are some non-negative integers. So the first theorem is, let x be a rational number whose decimal expansion terminates. Then this x can be expressed in the form p by q, where p and q are some co-prime, and the prime factorization of this q is of the form 2 raised to n into 5 raised to m, where n and m are some non-negative integers. Okay, next you will have a doubt that for every rational numbers having the denominator 2 raised to n into 5 raised to m form will have a decimal expansion which terminates. That means every rational numbers having the denominator 2 raised to n into 5 raised to m form will have a decimal expansion which terminates. Of course it will have. We can go through the reverse process of the examples we have done in the first page. So we are going to do this. That is, 3 by 8 can be written as 3 by 2 cube. Here 8 is written as the power of 2, and now in order to get the power of 10 in the denominator, we have to multiply this denominator with the 5 cube. And when multiplying this denominator with the 5 cube, we have to multiply the same in the numerator, and we are now getting 375 dividing by 10 cube, and it can be written as the decimal form 0.375, that is terminating decimal expansion of this rational number. And next is the 13 by 125, and that is equal to 13 by, this is written in the power of 5 cube, that is 5 cube here, and in order to get 10's power in the denominator, we have to multiply this denominator with the 2 cube, and if we multiply this with the denominator with 2 cube, we have to multiply the same in the numerator, and we get 104 dividing by 10 cube, and the decimal expansion is 0.104, which terminates. Next is 7 by 80. That is, this 80, the prime factorization of 80 is 2 raised to 4 into 5. Then, in order to get the tens power in the denominator, we have to multiply this denominator with 5 cube, and so we are multiplying the same in the numerator, and we get 875 dividing by 10 raised to 4, and that is equal to 0.0875, which is the decimal expansion of this rational number, which terminates. Next is 14,588 dividing by 625. The prime factorization of this 14,588 is 2 square into 7 into 521 dividing by 5 raised to 4. And in order to get the tens power in the denominator, we have to multiply this 5 raised to 4 with 2 raised to 4. And in the same 2 raised to 4 has to be multiplied in the numerator also. So we get here 2 raised to 6 into 7 into 521 dividing by 2 raised to 4 into 5 raised to 4. That will be equal to 2,33,408 dividing by 10 raised to 4. That is equal to the decimal expansion 23.3408, which is a terminating decimal expansion of this rational number with a denominator 2 raised to n into 5 raised to m form. So that is what saying in the second theorem, that is, let x equal to p by q be a rational number such that the prime factorization of q is of the form 2 raised to n into 5 raised to m, where n and m are non-negative integers. Then x has a decimal expansion which terminates. Okay. Next we can go through rational numbers with non-terminating repeating decimal expansions. Okay, we have given an example here, 1 by 7. Now we are going to divide this 1 with 7, that is 1 dividing by 7. Now we get 0. So we are giving a point and adding a 0 here. We get 7 will go in 10 for one time, and that is 1 into 7 equal to 7. The remainder is 3. Adding the 0, we get 30, and 7 will go in 30 for 4 times. 4 into 7 equal to 28. The remainder is 2, and adding the 0 again, we get 20. 7 will go in 20 for 2 times, that is 2 into 4 is equal to 14, and the remainder will be 6, and adding the 0, we get 60. 7 will go in 60 for 8 times, that is 8 into 7 equal to 56, and here we get the 4 as the remainder. Adding the 0, 7 will go in 40 for 5 times. 5 into 7 equal to 35, and again the remainder is 5, and in 50 the 7 will go for 7 times. 7 into 7, 49, and the remainder will be 1. Again adding the 0, we get 10, and 7 will go in 10 for 1 time, that is 1 into 7 equal to 7, and the remainder is 3. Again adding the 0, the 7 will go in 30 for 4 times. Like that, this will be repeating 3, 2, 6, 4, 5, 5, 1. These reminders will be repeating, and also in the quotient we will get a non-terminating repeating decimal expansion. That is here 142857, 142857, 142857. That will be the quotient of this division, and that will be a non-terminating with no end, and also will be a repeating, that is 142857 will be repeating. And that is here in this example. Let's see the denominator. Here the denominator 7, the prime factorization of 7 is 1 into 7, and look at that. Is it in the form 2 raised to n into 5 raised to m? No, it is not in the form 2 raised to n into 5 raised to m. That is what's saying in the third theorem, that let x equal to p by q be a rational number such that the prime factorization of q is not of the form 2 raised to n into 5 raised to m, where n and m are non-negative integers, then x has a decimal expansion which is non-terminating and repeating. Okay. The points are, if the denominator of given rational number can be expressed in the form 2 raised to n into 5 raised to m, then its decimal expansion will be terminating. And if the denominator of given rational number cannot be expressed in the form 2 raised to n into 5 raised to m, then its decimal expansion will be non-terminating and repeating. That is, the decimal expansion of a rational number is either terminating or non-terminating. Okay friends, hope you understood, and in the next video we can discuss the problems relating this topic. Okay. If you like this channel, please subscribe the channel and share with your friends. And if you have any doubts and suggestions, you can mail me at friend4maths@gmail.com. Okay friends, see you in the next video. Till then, take care. Bye.